I have a query solution in React that gets rid of this garbage. No more spamming use effects and having multiple different use states to manage a single query. This solution is what the vast majority of professional grade apps in React use. It will make you go from writing querying like this to this. The solution that I'm talking about is, of course, TanStack Query, which most people just know as React Query. And in this video, I'm going to show you exactly how to use it as fast and efficiently as I can. TanStack Query is a querying and state management library that makes querying super easy and efficient. In a super short summary, what it essentially does is provides hooks that have reactive state, loading state, error state, refetching capability, all built into one hook. Under the hood, it uses a query client that keeps track of all the queries in your app, and it will automatically cache queries and use that cache to make queries as fast and efficient as possible. I could talk about all the features for 30 minutes, but let's cut right to the chase and I'll show you exactly how to use it. Here's how to get started with TanStack Query. To get it into your project, go into the terminal and run the command npm @tanstack/react-query. Once we've run that command, we're good to start adding TanStack Query to our code. First and foremost, before we can actually do any querying, we need to wrap our app in a query client. Query client is the backbone of TanStack Query, and without it, any TanStack methods we call would have zero context on how to fetch and retrieve data. So what we always do first is initialize the query client, typically within the main.tsx or app.tsx file. I'll do mine in main where we're actually rendering our app. Up here, I'll just go ahead and write const query client equals new query client, just like this, and we'll make sure that's imported from TanStack. And it's important that this query client exists outside of an actual React component. Next, we want to wrap our app with query client provider, meaning the app will be between the opening and closing tag of this provider. So we can just spell it out like this, query client provider. Again, import this from TanStack. Go ahead and give it an opening and a closing tag, and we'll wrap our app in it just like this. Go and save it to get some formatting. And you'll see we have an error here. It says we need to do a client, and that's actually what we're going to pass in the client that we just made. So we're going to give it a client prop, just like this, where we pass in query client. And that's all that it takes for initializing the query client. Now, anywhere inside the app, if we call any TanStack functions, we know that we're referencing this query client right here because we wrapped it within this provider. Now that we have the setup done, we're ready to get started. The core of TanStack Query is the use of the useQuery hook. It's how we actually query for data. How we'd use it is pretty simple. We'd make a variable, I'll just call it query, and we would set it equal to useQuery. This would be a function, again, imported from TanStack. It takes in one primary argument that is an object. This object needs two properties to work properly. The first property is a query key, which we can just write as query key like this. And query key is going to be an array. The query key is used for refetching data and caching data, so it's super important that we have this. This key can be anything, but above all, it needs to be unique. That way we know which query that we are referencing. If it is not unique, let's say another query shares the exact same key, the query client is not going to be able to distinguish between the two of them. So let's say this query in particular is fetching some to-do items. We could just pass in a string called to-dos in our array here as our query key. We can change this later, but this will suffice for now. The second property of this object should be a query function denoted as query fn. This is a function that will run whenever we run the query with this key. This is the function where you would put your API call, meaning your fetch, Axios, or whatever else you're using to get your data. I'll just use fetch in my example, and we'll actually extract this out into its own function to make it easier to read. So just down here at the bottom of the file, I'll make a function. I'm going to call it const getToDos. And this will be an async function. And inside this function, we're going to do something pretty simple. I'm going to make a variable for our fetch call. I'm just going to call it const response equals await fetch. And I'm going to pass in this link here that will act as our mock API. If you go to the URL of the link that we just pasted in, you can see that it generates some JSON data. It's just an array of some to-do objects that just have some random stuff in them that we're going to use to test our querying. If you're familiar with data querying, you know that at the most basic level, this is generally how we do it. Before you get out of this function, all we're going to do is we're going to return await response.json. That way it gets parsed as JSON data. And now this is going to be the query function that we're going to use for the useQuery hook. So this function is complete. And up here for our query function, we're just going to plug in getToDos just like this. And just make sure we're not actually calling this function here. So we don't want parentheses on it like this. We just want to pass in the function straight up. Now our useQuery hook is all good to go. But your next question is probably, what is this actually doing? And more importantly, what actually is this query being assigned to? We're assigning it to this useQuery with all this stuff passed into it, But what does useQuery actually return? This is where you realize TanStack is legit. If we head over to the TanStack docs and look at the documents for useQuery, this stuff right here is everything that is returned from useQuery that we could extract in our code if we wanted to. Data right here is the most important thing. That's what actually contains our parsed response. We also have helper booleans like is error, is fetching, is loading, is paused, is pending. You get the picture. Point is, there's a ton of stuff here and we could extract as much or as little as we actually needed. As I said, data is the most important return from useQuery. So in our code here, instead of just making this variable here called query, what we can actually do is destructure this and we can get data out of it, just like this. And just to give you a little cheat code here, if we don't have anything in our object and we do control space in VS Code to get the IntelliSense, we can get all the things that we could possibly pull out of useQuery, data being one of them. But as you can see here, we can see everything that we just saw in the docs, but we will choose to pull out data. Let's see what we actually got for our data. So in our JSX here, instead of saying something blah blah, we're going to go in here, we're just going to json.stringify and pass in data, go ahead and save our page. If you look over on the right here, you can see we got all the to-do data all on our page here. Just to make this not so overwhelming, I'm going to go into our data here and just take the first couple of entries. I'll just do .slice 010, just so we can grab the first 10 entries so you can see them on the page here. Now your next question is inevitably going to be, okay, that's cool and all, but what's so special about TanStack? Well, I'm glad you asked. Let's actually take a minute to explore some of the things we could pull out of useQuery, looking at our IntelliSense here. I want to add a loading spinner on this page now, whenever this data is loading into the page. So I'm going to find is pending here, pull that out of useQuery, and then let's do something with this. I have this loading component here in my app, so let's actually use this as pending boolean that we just pulled out of useQuery. We'll say if it's pending, then we want to display that loading spinner, and if it's not pending, meaning that data is loaded in, we will just display our data. If I go ahead and save this and then refresh the page, you can see for a very quick split second, the loading spinner appears in the page, but it goes away so quickly because the query happens so fast. To simulate a fetch taking a little bit of time, I just added this timeout here to make sure it waits an extra second before the query is resolved. Now if I go ahead and refresh the page, you can see the loading spinner appears in the page until the data is done and loaded in, and then it displays. Let's say that we now want some way to refetch this query. I've made this button right down here that we want to refresh the query whenever we click it. I don't need to write a bunch of logic inside this onClick to refetch it. All that I need to do is go into our useQuery, get the control space for IntelliSense, find the refetch function, which is down here, extract that out of useQuery, and then in our onClick here, all we have to do is pass that in as a function and refetch the query. Go ahead and save this here. Now if I click the refetch button, our query is going to refetch itself. If you notice whenever I click the refetch button, we don't actually see it happen with the loading spinner, for the same reason that we don't see it every time I would save this file in the page hot reloads. It's because this query right here that we're doing is cached using this query key. We've already queried with this key before, so that tells TanStack when we call it again that it's already in the cache, meaning when we click refetch, all it has to do is look in the cache and load in the data, hence why it's instant and we don't see a loading spinner. I'm sure you noticed that when we were looking through the things we can pull out of useQuery, there were other booleans like is loading and is fetching. If we wanted to see it every time, whether it's cache or not, we could do something like is fetching instead of is pending. So we can say is fetching like this, save it, and now every time I save the file, or every time I click the refetch button, it's going to show the loading spinner because it is fetching. But for our purposes, we're going to use is pending. The primary difference is that is fetching is whenever the query function is running at all. Is pending is if there's no cache data, and is loading, which I'm sure you've seen as well, is whenever it is executing for the very first time. Usually I like to use is pending in most scenarios. Occasionally I will switch to using is fetching or is loading, but it's important to know the differences. We've already seen a couple of these things used out of useQuery, that being data, is pending, refetch. What if there's an error? Well, luckily we can actually pull an error out of here as well. And we can just look in our query, say if there's an error, like going down here, just saying if error, then we can alert and say, something went wrong, just like that. But if I go in our fetch down here and I mess up this URL to make it something that doesn't actually exist, I go ahead and save it and refresh the page. It's going to have this error here and it might take a second. Eventually it's going to error out and it's going to say something went wrong. There you go, hit an error. Super easy way to do error catching. So I'll go ahead and just Control Z this, take it back to what it was. and change it back to normal, refresh the page to go ahead and fix itself, and we have our data back. I could go on and on and on about how to use all these different utilities returned from useQuery, but the point is, everything we could possibly want in a query, from the data itself to the loading functionality to error catching, is all contained in one hook, this useQuery hook. No more spamming useEffects and having 5 pieces of state that all manage the querying. It's all consolidated into one hook, and it does caching built in to make it fast and efficient. One very common use case for querying is needing to pass in some parameters to the query. For example, if I have an endpoint that needs an ID, and that ID might change depending on what we're doing. A great example would be in this mock API over here, this comments endpoint that just takes in a post ID, so it can fetch all comments that correspond to that particular post. So let's say in my app, I have an ID stored in a piece of React state, and it just defaults to the number 1. I also have this button down here that says increment ID. Every time I click it, we'll just increment the ID by 1. Now what I want to do is plug this ID into our query. The most important thing that you do is to pass this ID into the query key right here. To do that, we can simply add to this query key array by adding a comma here, and we're going to add ID to the end of it. And this step is super important because if I don't pass in this ID to the query key, TanStack won't be able to accurately cache the query. For example, let's say I have 2 scenarios on this page, one where ID is 1 and one where ID is 2, which could very well happen because we have a use state that increments them. If this ID isn't part of our query key here, those queries will be identical in the eyes of the query client, which means our queries won't behave as expected and is going to result in some problems. But what adding this ID does is tells it that if ID is 1, that query is going to be a different query than if the ID is 2, and that differentiates them. So it's super important that if you have variables on a query key like this that are going to change what the result is, that you have that variable as part of the query key. The next most important thing is that you actually pass the parameters through to your query function. So in our case, we want to get it to our getToDos function. I've changed this query down here, this getToDos, to now accept an ID argument, and then it just adds that ID to the end of our fetch here, so that we're mimicking the exact fetch on this mock API right here. So now this should match. So if we go up here, we're going to want to pass that ID into our getToDos. We don't want to actually call this function manually. We want to pass it through for TanStack to use. So if we just add the ID like this to the end of the function, that's not going to work. And you see we're going to get a TypeScript error here because this isn't valid. We need to add the parentheses in front of here, make it an arrow function, just like this. So we're passing in the function definition, not a function call. Now that we have this, it should behave as intended. So if I go ahead and save this file here, you can see it's loading in some data, and it is loaded in some comments from a particular post, that post being ID number 1. If I click increment ID, notice how it's going to load again, load in more posts that have a post ID of 2. And I could do this any number of times, and each time it's going to load in some unique data, because each time we're incrementing the ID, we're hitting a unique endpoint. And I can actually show you real quick what happens if we don't add that ID to the query key. So if I take that away, go ahead and save this, see that we have some post here, it just randomly jumped to post 5 for some reason. If I increment, nothing happens, because TanStack has no way of differentiating which ID is which if we're not passing into the key. But if we go ahead and pass it back in here, save the page, it's going to hop back on the correct behavior, starting at 10, going to 11, and so forth, because now with the query key, it can figure out which query is which. And this is exactly how you pass in parameters to your queries. It's always going to look something like this, or at least it should in most use cases. If you're familiar with the basic hook rules, you know that you cannot call hooks in React conditionally, so conditional querying is not made easy with vanilla React. One really cool thing about the useQuery hook is that you can conditionally call queries somewhat. For example, if I have a Boolean React state up here that is just on, like an on-off switch, that is just true or false, there is a way to make useQuery only automatically run when the state is true, and never run when it is false. useQuery makes this super simple. As part of your query options here, in addition to having the query key and the query function, I can specify another field that is called enabled, which you can see the IntelliSense picks up on here, and I can just pass in a Boolean for that. When this Boolean is true, this query will automatically run. Whenever it is false, it will not automatically run. And what I mean by that is we can still get the query to run if we manually force it to, like in the event of calling the refetch function, but it's not going to run every time React re-renders this component. This is really helpful in scenarios where maybe you have multiple use queries in the same component, and you only need certain ones depending on some state in your component. I'll show you a really neat use case of this closer to the end of the video. One thing that you might notice when working with TanStack is sometimes your query options can get a little bit complex. For example, if I look at all the possible options for the query options, you can imagine that if I had a bunch of these on here, this file could get quite a bit messy. One thing that I like to do is make my query options in a separate file, not only for this issue, but also to make my queries reusable across my entire app. What I typically do is make a folder somewhere in my directory called something like query options, and then I would put all of my query options in here. If we're talking about just this query for this to-do that we've been hitting earlier, we can make a file in this folder just for that query. So I would normally name it something along the lines of create to-do query options.ts, just like this. This would just be a function called create to-do query options, and then it would just return query options, which is from TanStack. What's nice about using this query options utility is that you can get type safety and IntelliSense versus just using a straight up object. For example, if I try and pass in an object here to get our options, and I click Control Space for IntelliSense, we have the IntelliSense of it telling us everything that we could possibly pass into this. So that's kind of just a useful thing to have. So what I will actually do now is go back to where we have the query options already created, and it's this object right here. I'm going to go ahead and take this, and I'm just going to pass it in to our query options just like this. And we have our get to do's function here. Let's actually get rid of enabled. Let's say we don't want that in this case. And for now, normally I would put this in a separate file, this function, but for right now, we can just move it to here. So it's happy. Now we have this create to do query options function that can be called anywhere in our app, so we don't have to keep rewriting the query options if we're calling it in multiple places. How we'd use it is super simple. We'd first want to make sure, obviously, this is exported. So let's just export default function, create to do query options, go ahead and save this file. And now in here, instead of having to actually do all this with the query options, we've already just created that. All we need to do is call the function create to do query options, just like this. Call it like a function and it'll be happy. And voila, it behaves the exact same as before in the exact same way you would expect it to. However, we just extract it into a separate file. So now we can use this wherever we want in any possible component, and we've made it modular and reusable, which is definitely nice to have and something I definitely recommend if you're in a medium to large size app. Next, I want to talk about something with TypeScript. If you're using TypeScript and all that your query function is doing is simply using fetch and then returning that as a parse JSON response, you're going to notice one thing. If I go into where we're using useQuery and I hover over data, notice how data is of type any. Having a data of type any means that you're not going to get any sort of type safety when working with this data object. So if in my JSX I try and do something like, let's just replace this down here, I just try and do something like, I don't know, data.hello. I'm not going to get any problem saying that this property doesn't exist, even though it genuinely does not exist. But TypeScript doesn't know that because data is of type any. And the only way it's going to eventually find out about that is if I save the file, the page is going to crash because obviously we have an error. It's going to say we can't read this property because it doesn't exist. So now nothing's displaying on the page. But TypeScript can't catch that if it doesn't know what it's supposed to look like. So if we go back to what it was before, I'll show you a way that we can fix this. One way that we can quickly fix this is to specify the return type inside of our query function here. If we know the structure of our endpoint response, we can make a type for it. So for example, if we go over to this tab here and we look at the general structure of this data here, we can see what it looks like. We have a user ID that's a number, ID that's a number, title's a string, and completed is a Boolean. So let's actually go down here and make a type for that. So we would say type to do, something like this, user ID is going to be a number. We would say ID is a number, title is a string, and then completed is a Boolean. And this could be the type that we would use for our return. Now on our query function definition, we can specify that we want the return type to be of type to do. And it's going to be an array of these objects, so we can add square brackets. But one last thing, remember that when we're working with async functions, that it's always going to be a promise that we're returning. So let's wrap this in a promise, just like this. So we are returning a promise of an array of to-do objects. If we now save this file and then go back to our app and hover over data, notice this. It's now telling us that it can be of type to-do or an array of type to-dos, or it can be undefined, which is pretty standard. What this implies now is that if I go into our JSX down here and I try and access a property of data, we get the first element in data, and I try and access something, and I could do any one of these properties, and there would be no error on this because these are all valid properties. However, if I try to do something like hello, it's going to have an error now saying hello doesn't actually exist. So this is one easy way that if you know the structure of the response, you can just type it manually in the function. That way you can get type safety when working with data. In a more complex app, you might consider using something like Zod that will do runtime validation for your types. Right now, we're just telling the fetch function what the return should look like, but if there's an actual mismatch between what we put in this type and what the endpoint actually returns, we're most likely going to end up with errors. But this is a topic for another video. However, let's go back to one thing real quick. If we're back on this page and we hover over data, you see you have a red squiggly line here that says data is possibly undefined. And this is actually the default behavior of the useQuery hook. If you're working with TypeScript, this can be annoying sometimes because anytime you try to access properties of your return object or array, you may get type errors saying it could be undefined. And that's absolutely valid because it could be undefined. If you want to use a query where the data is guaranteed to resolve before it is returned to you and it can't be undefined, there is another hook in TanStack called useSuspenseQuery. And it works very similarly to useQuery, except that it guarantees that data will never be undefined. And here I want to show you exactly what I was talking about. If I take this query right here, and I go ahead and just copy and paste it up here, and instead of using useSuspenseQuery, I just use regular useQuery. Now if I hover over these, look at this. The data for the useQuery is going to be of type to-do or undefined. If I hover over the data for useSuspenseQuery, it is only of type to-do, not a union with undefined. I'm getting an error here because I have two things that are of the exact same name, so I'll go ahead and delete this. But case in point is that the useSuspenseQuery is great for when you're working with things you want to make sure data is always defined and there's no undefined case. What it's also great for, and actually what its primary use is if you're wanting to use the React Suspense component. So for example, let's say I have a card component that is being rendered in my app. Inside the card component, I have a useSuspenseQuery that is fetching some data. It is the same exact useSuspenseQuery from before, I've just moved it down a layer into this card component. Wherever I'm rendering the card, I can actually wrap this card here in a suspense, just like this, and this is from React. So you put this between the opening and the closing tag of the suspense, just like this. I can go ahead and give this suspense a fallback prop here and just pass in a loading spinner component. Now what this actually does, in conjunction with useSuspenseQuery, is if there are any suspense queries inside of this suspense right here, for example, the one that we have within the card, it will render the fallback component if the query is not yet resolved. Otherwise, it's going to render out the card. This is a very common way loading state in React is handled, and the useSuspenseQuery is great for this. So now if I go ahead and save this file and I refresh the page, notice how we have a loading spinner until the query is resolved, and then it displays the actual card. So I'm not having to do like a ternary checking whether it's pending or not. This is just a suspense that the useSuspenseQuery is really good for handling. If you haven't seen this pattern before, well, here it is, and useSuspenseQuery is a great way to do it. The one downfall of useSuspenseQuery that I found thus far is that unfortunately you can't use the enabled property on useSuspenseQuery to mimic conditional querying. So what I mean by that is if I were to take this whole thing, make this an object, do a spread on this, and then add enabled to the end of this here, and I try and add some fake Boolean like this to mimic the conditional querying that we can do with useQuery, it's going to say that I can't do enabled on here. It doesn't exist on these useSuspenseQuery options, and that's because it actually doesn't. The whole deal with useSuspenseQuery is that it guarantees the query will return something, and adding a conditional that triggers the query sort of breaks that behavior. You technically can simulate the same behavior by passing in your own sort of enabled Boolean, and then, somewhere inside the query function, like inside here, we could have, something that would say if this thing is true, then return null, otherwise go through with the query or something like that. The problem is if you're returning like this, now you've just made null a potential return type, and at that point, you might as well just use useQuery. So if conditional rendering is something you want to do, use useQuery, and if you're trying to use useSuspenseQuery, just know that you can't do the enabled tag and conditional querying like that. One of the great things about TanStack is that you could have as many queries in the same component as you need. Sometimes, especially in larger apps, having the ability to have multiple queries in the same component is necessary. I'm going to split this section of the video into two parts. Part one being when you have multiple queries that are exclusive to each other and can all be ran at the exact same time. Part two being where you have multiple queries, but they need to run in a certain order, because the results of one query might impact the options passed down into the request of another. For the first scenario, where we have multiple queries that are all completely independent of each other, there is a super easy utility function from TanStack that allows us to execute all of our queries together without having to call each one separately. This function is useQueries. Yep, literally just useQuery, but plural. Rather than taking in a single query, useQuery should take in an array, and here's where we can list whichever queries we want. To call useQueries, all we need to do is replace useQuery with useQueries, make sure that is imported, and rather than taking in a single thing here, this actually is going to take in an array of possible queries. And actually, this should still be an object here, so this should just be an object with a property called queries. And then this is where the array itself is passed in. Off screen, I just created 2 more queries, so we now have a total of 3 that we could possibly run. Now that I have multiple queries that I want to run, I can go back to the use queries here, and in this array, I can add another one. I have one called create user query options, and I also have one called create post query options, just like this. Let's go ahead and call this like a function, save it to get some formatting. And here you can see we are calling all of these queries right here. And instead of this being destructured as data, what we instead need is to destructure as an array, because what it returns is an array, since we're passing in as an array in the first place. And we could just do something like result1, result2, result3 like this if we wanted to, where it corresponds to the correct order. So this is the result for this first one. This is the result for the second one. This is the result for the third one, that being in this order. Or we could also do what we did before, where we just destructure data out of these. And if we save it, you can see it'll behave the exact same way. This useQueries hook provides an easy way to consolidate all of our queries into one function. Now, there's nothing inherently wrong with using multiple useQuery hooks, but if you wanted to do it this way, this would be an option. What's awesome about useQueries is that it doesn't just apply to the useQuery hook. There is also useSuspenseQueries, just like this, that behaves in the exact same way as useQueries, but it acts as a suspense query instead. And this method of doing useQueries or useSuspenseQueries is great if you have all the queries in the same file that are exclusive of each other. But if the parameters of one query rely on the results of another, this does not work. For example, let's say I have a scenario where I have 2 queries in a single component. The first query retrieves all the users from an endpoint, and the second query takes a ID that is a random ID from the users and then plugs it into this create post query options, where we're getting a post based on a random user ID. Obviously, these queries can't run at the exact same time because the second query right here is dependent on this ID, which is dependent on the first query. So they can't run at the same time, they have to run one after the other. I showed you the enabled Boolean earlier, and that's exactly how we can actually get around this. In the second query, I can take this here, put this in an object, and just spread it so we can add some properties here. Scroll to the end here, and I can just add an enabled Boolean, and we will just check to make sure that this users is not undefined, essentially. So we're going to say if users, and we can turn this into a Boolean by adding double exclamation point. So essentially, if users is defined, we're going to enable this query. If users is not defined, this query is not going to automatically run. Alternatively, if we didn't want to do it this way, there actually is another way to do it. If we made this first query a suspense query, that is going to guarantee that users is going to be defined here. In which case, we wouldn't have to put the enabled tag on this, because it's kind of redundant in the sense that this is checking for if it's undefined or not, but we already know because we're doing a suspense that it will be. So we could just get rid of this like that, do it as a suspense query, and it should behave in the exact same way. And with that, we're going to end this video here. I've covered some of the main talking points of TanStack, but there's so much to this library that I'll certainly be covering more TanStack topics in future videos. I hope you were able to learn something from this video, and if you don't already use it, I'd highly encourage you to use TanStack in your React projects, as it helps tremendously and is a legitimate professional way of handling querying. Take care everyone, and I'll see you in the next one.